Myself, J. Abdul Rahman, and my teammates for the project are AK Abdul Rahman and Darun M. Our project is named a multimodal chatbot for dynamic resume-based interviewing and report assessment. Uh, yeah. So the problem statement. When we looked at the current recruitment landscape, we saw a massive gap. Companies are stuck between two extremes. On one hand, you have human interviews. They are great for nuance, but they don't scale and they're prone to bias. And also, traditional technical recruitment is trapped between two flawed extremes, expensive, time consuming human interviews that create severe hiring bottlenecks. And on the other hand, you have automated coding tests. These are scalable, but they are rigid and binary. They only tell you if the code works. They don't tell you how a candidate thinks, how they reason verbally, or how they handle pressure. Furthermore, static assessments lack adaptability. A single nervous stumble can unjustly disqualify a strong candidate, while rigid questions bank fail to probe the true depth of the exceptional talent. Our system, the AI interviewer, bridges this gap. We have built a platform that doesn't just listen to what you say, but analyzes how you say it. It's an adaptive voice first system that mimics a high level technical lead. The AI interviewer is an adaptive voice driven assessment platform that revolutionizes technical screening by simultaneously analyzing what a candidate says and how they say it. Um, Upon ingesting a candidate's resume to generate a personalized skill matrix, the system also utilizes a rating algorithm known as glycostyle, which changes according to the difficulty level of the question based on real-time performance. And at its core is a dual stream architecture process, which is separated into two streams, which is semantic engine, leverages Whisper and Grok hosted language models to evaluate technical accuracy, while a parallel prosody engine uses UMA to measure different emotional markers like doubt, anxiety, and determination. So this combination or holistic approach uh, also provides a comprehensive report and nuanced data-driven profile of both candidates' technical depth and their vocal confidence under pressure. As we see in our literature review, we didn't just build this in a vacuum. We looked at Yang et al. 2025 to understand how to separate semantic channels from emotional ones. We also heavily researched Pelanek 2021 to move away from static difficulty ladders. Instead of just getting a question one, question two sequence, which is kind of predictable, our system uses a glycol style rating algorithm, as explained before, the same math used in competitive chess to estimate a candidate's ability in real time. But this came with challenges. We had to solve for latency, orchestrating for different cloud APIs, which is Grok, Loom, Whisper, and MySQL simultaneously. We also had to tackle technical jargon, making sure the STT doesn't fail when a candidate says complex terms like polymorphism or idempotency. And the last or one of the challenges is LLM hallucination in grading. So, preventing it prevents the semantic evaluation engine from hallucinating grades or being ticked by a candidate who just only uses the correct vocabulary but applies it to the wrong logical concept. So, moving on, uh, the next few challenges will be the network volatility and state recovery. So handling sudden web discussions and API rate limits, and on over that MySQL connection drops mid-interview without losing the candidate's progress or cluttering the database with orphan session. And last one is audio quality and dead air. So processing silent, ultra short or highly noisy audio clips where the deep learning prosody model fails to detect measurable emotional markers like determination or doubt. Yeah, now let's look at the main part of this project, which is architecture. So as you can see in the diagram, our architecture is divided into three distinct layers. At the top, we have the HRL engine or the brain. This uses hierarchical reinforcement learning. We have a macro agent that decides which topic to probe based on the resume, and a micro agent that tracks the candidate's ability rating and uncertainty band. The client tier captures audio via WebSockets. We choose the Flask socket IO because traditional HTTP requests are too slow for real-time interaction. For example, when a candidate speaks, the audio bytes are streamed to our application server. From there, we hit our dual stream evaluators. This is where the multimodal aspect truly comes alive. Stream 1 is semantic. It's handled by Whisper Large V3 Turbo on Grok for near instant transcription. Stream 2 is the prosody stream. We use Hume AI to analyze the acoustic features of the voice, detecting micro expressions like determination, doubt, or anxiety. All of this data is then persisted in a MySQL database to generate a final reports. So proposed work, uh, we have some, we have like dynamic skill extraction. So the system first step of the this is by passing unstructured candidate resume PDFs using an LLM to automatically generate a personalized and weighted technical skill matrix. So, for example, if a student has high uh, like if he has more projects or more it's based on the weighted importance of a skill. So next will be adaptive HRL engine. So this replaces static questionnaires with hierarchical reinforcement learning, a macro agent which orchestrates topic selection, while a micro agent uses a Glico style algorithm to adjust difficulty in real time based on candidates performance. And yeah, dual stream evaluation pipeline. So as we discussed before, this is the main or the core innovation. It processes audio through two parallel channels, which is a semantic stream and prosody stream. So semantic stream uses Whisper speech to text and Grok, which is Llama 3, to grade logical accuracy against an ideal reference. Prosody stream uses Hume AI's deep learning acoustic models to extract emotional markers such as determination, doubt, anxiety directly from vocal tones. As you can see, the system requirements, we have hardware requirements such as multi-core CPU, and which is for handling concurrent web sockets, streams, and local STD. Memory RAM is 16 GB minimum, yeah, to prevent memory swapping when running local Whisper models. And storage will be 50 GB of free space. Peripherals, high quality microphone, and stable internet connection. And our software requirements are as Windows 10, 11, Mac OS. We mostly used Windows 10 or 11, and sometimes we also use Mac OS Linux. Backend framework is like Python, which is the main framework, and SQL, MySQL connector, and database management was our main preference. We used MySQL Server 8.8.0 plus, and the machine learning and APIs which were useful were Hugging Face sentence transformers, OpenAI Whisper, Grok API client, and Hume API client. This is the most elaborate part, so we need to talk about, which is modules. So the module one, I think we should be breaking down this into five core modules. So module one is a resume ingestion. We don't just search for keywords, we use an LLM based parser to read the unstructured PDF. It identifies the top four technical skills and assigns an experience weight. This seeds the HRL engine. So if your resume says you're an expert in Go, but a novice in SQL, the system knows exactly where to start the difficulty scale. So moving on to next module, 2, which is our hierarchical reinforcement learning engine. The glycosylation ability estimation, which plays a main role in this. In traditional tests, if you miss a hard question, you might fail. In our system, if you miss a level 8 question, the micro agent simply widens its uncertainty band and nudges the difficulty down to level 6 to find your true ceiling. It calculates the Fisher information of every answer to ensure we aren't just making random questions but the most informative one. Module 3, real-time generative interaction, which handles the interaction. We implemented a clarification logic. uh, if if to be explained clear, a semantic engine sees that a candidate got partial credit, say a 5 out of 10. The system doesn't move on. It generates a nudge question. It might say, you mentioned the basic concept, but can you elaborate on the specific logic for that approach? And this makes A feel like a human interviewer rather than a non-human or a AI interview, helping the candidate to reach the right answer. So module 4 is the dual stream engine. For the semantic stream, we use a hybrid approach, which is cosine similarity via all mini LM L6V2 for topical overlap and a strict LLM rubric for logical correctness. Meanwhile, the prosody stream is analyzing the audio for determination and hesitation. If a candidate gives a correct answer but the doubt score is high, the report will reflect that they might not be as confident in that specific skill as they claim. Finally, Module 5 handles orchestration and security. We use Bcrypt for password hashing to ensure candidate data is secure and a report lab engine to transform thousands of data points from the MySQL logs into a clean professional PDF report. So implementation and screenshots. So yeah, if you look at our implementation screenshots, you will see the flow in action. First, the user signs up and uploads their resume. The system immediately passes the skills. You can see it identified as Go. Yeah, here. Yeah, here you can see it identified as Go, Node.js, PostgreSQL. Once the interview starts, the UI is designed to be minimal to keep the candidate focused. The brain panel shows the real-time HRL state, the macro uncertainty and current difficulty level. On the right, we have the evaluator panel, which shows the explainable AI insights. It doesn't just give a score, it shows the candidate exactly what the ideal reference was and why the grader gave that specific score. Yeah, these are the other screenshots. So for example, the candidate has answered and has got a text score of 4 and a confidence score of 7.4. And you can see on the right, the grader has the exact sentence or the exact concept which the candidate needs to improve. And in this final executive report is where all the data converges. Uh, this is shown as also a download detailed PDF. You can see the trend lines uh, where we track technical performance versus vocal confidence across multiple interviews. This allows a hiring manager to see if a candidate is improving over time or if their confidence drops as the technical difficulty increases. Yeah, this is a session timeline recorded for each concept and for each question. Note noting and logging their technical score and confidence score. These are the strengths and hiring recommendation, and also the recommended learning resources. We provide them as a link directly to the source for the concept where the source where the student is lacking. We even have included a recommended learning section in the PDF. For example, as mentioned before, each question is linked to a specific Geeks for Geeks search URL based on a concept the candidate struggled with providing a clear path for interview. And this is the final screenshot where the candidate has his own dashboard, so he can see which interview he has done well, and even he can compare it with it, and also the trending lines which showcase the improvement or the deployment of the candidate throughout the interviews. These are the references which we have mainly, a few of the references which we have mainly taken ideas from. And yeah, conclude, our project demonstrates that automated interviewing doesn't have to be cold or rigid, but by combining HRL, which is hierarchical reinforcement learning, with multimodal analytics, we have created a system that is fair, adaptive, and deeply insightful. It saves hundreds of human hours by providing a more nuanced look at talent than any static test ever could. Thank you for your time. This was our presentation for the project.